Hello everyone. Today I want to explain you about the water soluble and fat soluble vitamins. So first come to fat soluble vitamins. Fat soluble vitamins are A, D, E and K. Hmm, We'll talk about vitamin A in this video. Vitamin A. The synthetic forms of vitamin A are retinol, retinoic acid and beta carotene. As you can see here, this is the structure of retinol. This is retinal and this is the structure of retinoic acid and beta carotene. This is the structure of beta carotene. All the three retinol, retinal, and beta carotene are interconvertible, but whereas retinoic acid, it is not interconvertible. It cannot be transformed into either into retinol or retinal, not beta carotene. So first, we'll talk about retinol. Retinol, vitamin A alcohol, primary alcohol containing beta iron ring. Side chain has two isoprenoid units, four double bonds, and one hydroxyl group. It's not destroyed by heat, so as you can see, it's not heat sensitive, so we can cook it. It will not be destroyed by the time of cooking. Due to the presence of double bonds oxidation, um, due to the presence of double bond, it is not heat sensitive. If it is single bond, it will get easily destroyed by the heat. So this retinol is mostly present in animal tissues. Let's come to retinol. Retinol, it's a vitamin A aldehyde. Aldehyde from vitamin A obtained by oxidation of retinol. As retinol gets oxidized, it forms retinol. As I already said, it is interconvertible. It can be converted into retinol again or beta carotene. So retinol and retinol are interconvertible. Retinoic acid. Vitamin A vitamin A acid produced by oxidation of retinal. So again, by oxidation of retinol will be formed. By oxidation of retinoic acid will be formed. It's not interconvertible as I said earlier. Beta carotene. It's mostly found in plants. Beta carotene possesses one-sixth activity as compared to that of retinol. These are the structures. Digestion and absorption. Retinal esters. It gets hydrolyzed by pancreatic and brush border enzymes, and retinol and free fatty acids are released. Carotenes reduced to retinol, incorporated into chylomicrons. As you know that body cannot absorb fat, um, um, it will get into chylomicrons. The proteins it will surround the fat globule, and it will be entered into the body. It will be absorbed, and again it forms triglyceride. It will be converted into triglyceride form when once it is absorbed in the small intestine. It's incorporated into chylomicrons and transferred to the lymph. Retinal esters are chylomicrons. Retinal esters of chylomicrons are taken up by liver and stored. These are stored in liver, and whenever it is required, it will be released. It will be released in the form of retinol. Zinc plays an important role in the mobilization of retinol. Retinol is transported to extrahepatic tissues by plasma retinol binding protein in association with prealbumin. Functions, biochemical functions. Vitamin A is mainly responsible for vision, proper growth. It helps in development of gonads. So it's directly proportional to the functioning of reproduction system. So maintenance of epithelial cells in maintenance of skin. Vision. The function was first calculated by Mr. George Wald. So it's obviously called Mr. George Wald cycle. Rods and cones. Retinopathy has two types of cells, rods and cones. Rods are 10 million in number, and cones are 5 million in number. Rods are responsible for the dim light, and cones are responsible for the bright light vision. As you can see over here, this is the cornea, this is the pupil, these are the lens, and this is the retina. This optic nerve, it will be connected to the brain, and this is responsible. The image, it is inverted. The image which brain get, it will be inverted, and the function of brain is just make it the way as it is, right? Called visual cycle. Rods contain a pigment called rhodopsin, a conjugated protein. It contains 11 cis retinol and protein opsin. On exposure of light, 11 cis retinol is isomerized and to all trans retinol. On nerve impulse is generated by opsin. As you can see, it is the protein opsin. Nerve impulse will be generated by it. All trans retinol is isomerized by retinal isomerase to 11 cis retinol, which combines with opsin to regenerate rhodopsin and complete the visual cycle. The conversion of all trans-retinal to all 11 cis-retinal is incomplete, thus most of the all trans-retinal transported to the liver. So basically it occurs in two places. One it is in the eye, and the second wall cycle it occurs in it takes place in liver, where where it is converted to all trans-retinol by alcohol, the dehydrogenase. All trans-retinol undergoes again isomerism, and 11-cis-retinol is produced. Oxidized to 11-cis-retinol to participate in visual cycle. As it is the cycle, again it will be converted into 11-cis-retinol. Again it will get isomerized. As the same procedure gets repeated, whenever um, there is a requirement of rhodopsin, its liver rhodopsin will be stored in the liver, and it will release whenever body requires it. Darkness, as rods get function for the functioning of rods. Bleaching of rhodopsin: when exposed to light, color of rhodopsin changes to yellow, called bleaching. Occurs in few milliseconds. As you can see, color vision is governed by three color-sensitive pigments. It's porphyropsin, red; iodopsin for green; cyanopsin for blue. Whenever bright light strikes the retina, one of these pigments are bleached depending on the color of light. Other biochemical functions like steroid hormones regulate protein synthesis involved in cell growth and differentiation, etc. These are the sources: liver, kidney, milk, egg yolk, cheese, and fish are the sources. Vegetable sources: yellow and dark green vegetables. Deficiency causes related to eye, skin, and growth. Manifestation of eyes: night blindness. The deficiency of the vitamin A leads to night blindness, xerothalmia, white spot, and keratomalacia. Effects on growth: growth retarded due to impairment skeleton function. Effects on reproduction: degeneration of germinal epithelium leads to sterility in males. Termination of pregnancy due to fetal death is observed in few cases, not most. Effect on skin and epithelial cells: skin becomes rough and dry. Keratinization of epithelial cells of GI tract and urinary tract and respiratory tract occurs. Leads to increased bacterial infection, formation of urinary stones. This is the important point: hypervitaminosis of vitamin A. Excessive consumption leads to toxicity. Symptoms include dermatitis, enlargement of liver, skeletal decalcification, tenderness of long bones, loss of weight, irritability, loss of hair, joint pains, constant headache. Pregnant mothers, uh, pregnant mothers, congenital malformations in developing fetus. So it may affect all these things. That it may cause dermatitis if at all you just take vitamin A in more in quantity. That's all for this video. We'll continue in the next video. Don't forget to like, subscribe, and comment on our video. Food Tech Expo.